Okay, it's the last part from that video. The video has to be under 8 minutes or it won't upload for me. Just a small bit left on it anyway. So to find the length of AC. Okay, so we know that from the previous video that the triangles are similar, okay? And we can write them as fractions, then the corresponding sides, to make an equation, okay? Now for me, I find it difficult to see which sides are corresponding there because, you know, they're turned so differently. So what I would do there, and I don't have to, but what I would do is I would draw them separately so that I can see then which sides are corresponding. Okay, so I'm drawing the two of them, looking kind of similar. So I'm going to take the one on the left first. So we've got A, D, C. DC is 8. And then we have our dot is at A, our X is at C, and this red thing is at D. Okay, so the same this one, red, dot, X. Okay, so now I'm confident that they're both facing the same way. Okay, so this is the triangle on the left. I want to draw the one on the right now next. So on the right, if I look at which vertex is at the red angle, it's C. So I'm putting C here. Which vertex is at the dot? B. And which vertex is at the X? A. And I also know that AB is 22. Okay, so for me now that's much easier to visualize which sides are corresponding to which. Okay, now they've asked to find the length of AC. So AC is here. I'm going to call it X, the letter X. But AC is also on this one. Now, even though it doesn't look the same length on mine because I haven't been drawing them to scale, but they are supposed to be the same length, AC here and AC here. Okay, because we can see that they both share that side, that's common side on both triangles. Okay, so I'm going to call them both X. Right, so I'm going to take 8 here and put it over. So 8 is corresponding to X equals on this one. Again, I went with the left hand on top, the left triangle on top, so the left triangle here would be X over and over here 22. Okay, so the left triangle is on top, the right triangle is on the bottom. I could have done it the way around as well. Okay, as long as they're both on top. The same triangle is on top and the same triangle is on the bottom. Okay, now I have an equation I can solve because I have only one variable. Okay, so I suppose it was important to recognise at the start there that AC was on both triangles, otherwise I would have been short in number and I wouldn't have been able to solve. Okay, so we can only ever solve an equation anyway if there's only one variable. If there was more than one, we'd be going to simultaneous equations then. Okay, so if we cross multiply, we have x squared is equal to 22 by 8 is 176. And then x is equal to square root of 176. I suppose that won't be a normal number at all, would it? 4 root 11, or to one decimal place, 13.3. That'll be fine. Okay, so to tell you a question, I want to round it to, or whether to leave it in third form or whatever there. Okay, so that second example was quite important to prove that they were similar. We proved that the angles, the corresponding angles were equal. And then if in this one, if it's, I turned them first so that I could see clearly which sides were corresponding. And then any sides that were in both triangles, okay, any sides that had in common, we are to give them the same letter. Okay.